Hello friends, in the in the today's video what we'll be doing is we will be solving system of linear equations using the method called as Gauss Seidel, and we'll be using while loop to do so. So let us understand uh, how this Gauss Seidel works. So let us take one system of linear equation having two variables only, let's say. So let's say 3x minus y and x plus 2y, and let's say it is 2 and let's say it is 3. Now this system can only work well when the diagonal is heavy, that is the absolute value of the element at the diagonal is more than the sum of the absolute value of off diagonal elements, and here I am assuring that it is more or equal to that only. So the method will work well. So what this method says that we write the first equation having heaviest diagonal such that it becomes this. Then the second equation you write like 3 minus x by 2. That is bringing all the terms onto the right side, leaving x from the first equation, that is the diagonal term, and leaving y from the second equation, again that is a diagonal term for second equation. Now what we can do is we can assume certain values of x and y. Okay, so the next step will be to assume certain values of x and y. Let's say x and y both are 0, and take another variable x guess and y guess, starting guesses, which is 0, and basically we are assigning this value to x and y. Then what? Then we'll be evaluating the value of x and y, new value of x and y based on the guesses. But here we will be using this x is equal to 2 plus, now this we will be getting from y guess, but we have assigned it to y only, so it is 0 divided by 3, and then y will be 3 minus, now what is x here? It is 2 by 3, so it is 2 by 3 divided by 2, that is 9 minus 2 divided by 6. Then what we'll do? Then we will try to evaluate the error. So the error will be the absolute value of x which we have obtained minus the x guess which we have guessed previously, plus the absolute value of y minus y guess, and we will check. We will check what? If this error is less than certain convergence criteria, let's say it is 0.0001, if the error is less than this value, then we will say that x and y, they are my final answers. Otherwise, else what I'll do, I will say the new x which I have got is my x guess, so x guess is my new x and y guess is my new y, these values, and then again I will be going to evaluate these x and y's, and then again evaluate error and then check, and so on. So in this way this whole program will work till the error becomes a very small number. So 3x minus y plus is equal to 2 and x plus this. Okay. So let us start and let us see how to solve the system of linear equation using iterative method, that is Gauss Seidel, in C. So let us take x, y, and x guess and y guess. Okay. Let's say initially x guess is 0 and y guess is also 0. It depends on you. You can take any value. Later on I'll show this to you. Then what I'll be doing is I will be updating the value of x as x guess and y as y guess. Okay. Then I will be evaluating that, let's say I'm using one counter, count is equal to 0. So this is an integer. Okay. So this is my counter. That means how many times the while loop has uh, run. Then I have to also start with certain error. So float error is equal to, let's say, 1, because my converging error is going to be very much less than 1. It is 10 to the power minus 4. So, so uh, while the error is uh, more than 10 to the power minus 4, that is how we write in exponent form. So do what? First evaluate x. What is x? X is equal to 2 plus y by 3. It is 2 plus y by 3. Okay, then what? Then evaluate y. So what is y? So y is equal to 3 minus x by 2. So it is 3 minus x by 2. Okay, then go for the evaluation of error. Error is equal to, now the absolute, how to find out absolute? So that is, in math module there is a function known as FABS. So that will give you the absolute value of any number. So x minus x guess and then plus FABS of y minus y guess. Once error is evaluated, you also print it so that you will be in a position to understand how the program is going. So percentage f, let's say, or leave it, and then error is equal to this, and also count. So I is equal to count, and then uh, error is equal to this, and here I will be writing I and count. So instead of count, it should be the format specifier for count. It is percentage d. Okay, okay, then what? Once this is done, then if it doesn't converges, then we have to set x guess to x and y guess to y. Okay, for next iteration. So x guess is equal to x, okay, and y guess is equal to y. Now, what else? Okay, I have to bring this to new line. What else can be done? This counter has to be increased now. So count plus is equal to 1. I think it's done. Once the program is over, we can print the values of x and y's. So x is equal to percentage f, let's say 0.2, and y is equal to percentage f 0.2, and in place of first, x will come, in place of second, y will come, and then that's it. Now let us run this program and see what the error is. So it is saying I is undeclared. What is I? Okay, so I, instead of I, it should be count, and here it is error, so I should be printing error. So now you can see that as the iteration increases, the error slowly getting converged, and in the sixth iteration the x becomes 1 and y becomes 1. So this is one of the fastest method to evaluate the roots of any equation, any system of linear equations where the diagonal dominance is present. Okay, there is another method known as Jacobi method, that is somewhat slower in comparison to this, because here in Gauss Seidel we are just updating the value of the variable which we have evaluated in the same loop only. So if instead of x and y, x of this iteration only, if I take the x of previous iteration, then that will become Jacobi, and this takes more number of iterations. So let us take that only. So x guess, and this is, so this is y guess, and this is x guess. If this becomes, then there is no point of saying this. We can simply run it. Now you can see it has taken 12 number of iteration, just double iteration it has taken to arrive at the answer. So this method is called as Jacobi method, and the one which I have discussed previously was called as Gauss Seidel. So in this particular video we have learned that how to evaluate the root, how to evaluate the, or how to solve the system of linear equations using iterative method, that is Gauss Seidel, and we have implemented this using while loop. So thank you very much for watching the video.